All right, hey guys, let's take a look at, this one is, here we go, 3.2, part 3. All right, so we are going to look at your Pascal's triangle and see how that has to do with your polynomials. So let's see, the Pascal's triangle, this guy right here, it basically adds the two numbers above it. So you start with a 1. In fact, on the outside is always a 1. But then I'll do the 1 plus 1 to get the 2. So any two numbers in a row, I'm going to add them and get the number below it. So let's see, my 1 plus 2 gives me a 3. 2 plus 1 also gives me this 3. Okay. This would happen, honestly, you can keep it going forever. Any two numbers in a row, you get the number below it. All right, so let's see how that has to do with all the polynomials that we've been doing. We've been adding, subtracting, multiplying a bunch of different polynomials. So here are my binomials. Bi is in there are two terms, an A and a B. My A plus B to the 0 is just straight up 1. A plus B to the first is just A plus B. A plus B squared. Okay, so once we get to this point, you would have to have it squared. Like you would have to do all the distributing and everything. And once you do all the distributing, I get A squared and an AB. I get another AB and a B squared. So this is a 2AB in the middle. A squared plus 2AB plus B squared. That's how I got this guy. But do I really want to distribute every time if I don't have to? I'd rather use the Pascal's triangle. So the exponents here, like how many of the A plus B are all multiplied together, that is telling me the degree. All right, so it says the degree is the exponent on the binomial. So in this case, the exponent here on my binomial, the degree is a 2. So it would have to do with this whole part of Pascal's triangle. The A, let's see here. A is at the beginning, in this case a Y is at the beginning, added on to your B, which this was added on to a 4, so my B is a 4. All right, so there's my A, my B, and the degree. The next one, same deal, it's just all cubed in this case. Again, my exponent is telling me what my degree is, degree 3. So here's my degree 3. Here we go. This is my degree 3 where the A, okay, so the A is the first part that I am adding to the B. Keep in mind you're adding the entire 2Z. That whole thing, 2Z, is adding to the B here, which in my case is a 5. It's adding to 5. All right, so what else do we have here? They could have, again, an A plus B. This is all to the 4th in this case. So here's my degree 4. This lets me write it. There we go. So degree 4 in that section. The A, again, is what's added to the B. This is an M squared, including the exponent and everything. And, okay, keep in mind that this says plus B. Let's see, big old plus sign right here, plus B. But this guy says minus 2. I must have been adding a negative 2. So a negative 2 for my B in this case. Keep the sign on there. All right, so now it says use Pascal's triangle to expand the binomial. All right, so this one has a degree 3. So I'm going to go up to Pascal's triangle here. I'm going to use this guy with a degree 3. So the coefficients are the ones I got from this Pascal's triangle, 1, 3, 3, 1. So 1, 3, 3, 1. Those are all the coefficients. The A's and the B's, though, let's also look at those. So I'm going to use my coefficients of 1, 3, 3, 1. All right, I'm going to add all these guys. Okay, so those are the coefficients. Now, the A and the B, let's identify the A and the B. The A in this case is 3PR, and the B is a positive 2. Okay, so I need to, according to this part of Pascal's triangle, I need to do the 1a cubed, and then a is squared, and then a plane a, and then there are 0 a's. My a's are pretty much decreasing. A to the third, squared, plane a, and then none of the a's. So again, my a is 3pr. So I'm going to do that guy, that's 3pr. It was cubed. And then I've got a 3pr squared. It's going down by an exponent. 3pr to the first, which I don't need to write an exponent. And then I've got none of them here, 0 of the 3prs. Now let's look at the b's. In my case, the b is a 2, but the b's, let's see, at the beginning, I don't have any b's. There are 0 of them. Then I've got 1, and then I've got b squared. There are 2 of them. B cubed, I got 3 of them. So they actually do the exact opposite. They start at 0 and go all the way up to an exponent of 3. So at the beginning here, I have 0 of the b's, 0 of the 2's. And then I get a single 2, okay? And then I'm going to get my b squared, so 2 squared, and then cubed 2 to the third. Okay, as far as the parentheses go, because it's just a plain 2, I actually didn't need parentheses on those. That's fine. This guy as well, I have it on there, but it's not necessarily needed. I do need to simplify though. So make sure that you cube each of these. 3 cubed, so 27, p cubed, and r cubed. All times 1. Do I really need to multiply by 1 though? I might as well just leave it. 27, p cubed, r cubed. Okay, so if I distribute my 2 here on the next one, I get my 3 squared, so 9, and the p squared, and the r squared. Now I still have the 3 times all this stuff, and I still have the 2 on there as well. So we haven't messed with those. This one I actually don't have anything to distribute, so this one's just going to stay 3pr. So let's see, there's no exponent on this guy, so it stays 3pr, if it lets me write. All right, with the other 3 and the other 2 squared. 2 squared is 4, so I can simplify that down a little bit. Those are all multiplied together. And then the last bit here is 2 cubed times 1. 2 cubed is 8. 8 times 1 is still 8, so I'll just leave that the way it is. All right, last but not least here, let's get 2 times 3 times 9. So I'm getting 2 times 3 is 6, times 9 is 54. Oops, there we go. Come on. Okay. Still with p squared and the r squared. All right, over here I get 3 times 3 times 4. Just my constants here. So 3 times 3 is 9 times 4, so 36pr, and my 8. So at this point, I cannot combine any of these. They're not like terms. So that is my final answer. That is the expanded binomial. All right, so then number 5 here says to find the 8th row of Pascal's triangle. Let's look at the row that we stopped at up here. Let's see, we stopped at row 5. Okay, so row 5 of Pascal's triangle. So I'm going to pick it up from there. It was a 1, 5, 10, 10, 5, 1. So 1, 5, 10, 10, 5, 1. Okay, that was my 5th row. Let's go to the 6th, 7th, and then we'll go to the 8th row. So the 1's always on the outside. 1 plus 5 is 6. 5 and 10 is 15. 10 and 10 is 20. And have you guys noticed it's symmetric? It'll kind of do the same thing on the other side. So again, 1 on the outside. I'll add up my 1 plus 6, my 15 plus 6 also for the 21. And then my 20 plus 15 is 35. And then it kind of does the same thing on the other side. All right, and then last but not least here, 1 plus 7 is 8. I got my 7 plus 21, so I got a 28. All right, 21 plus 35, so I got 56. 35 plus 35, so 70. And now that's the middle, so it's going to, again, be symmetric. So 35 plus 21 is a 56 again. Down to the 28 again. And then 7 plus 1 is 8, and the 1 on the outside. Okay, so find the 8th row. Here is my 8th row. And that helps us with part B where we expand. So let's see, those are all of the coefficients now. Really long. 1 and 8, 28, 56, 70. Oh my goodness. And then that's only halfway through, and you get all the rest of them. 56, 28, 8, and 1. Okay. Self some space there. And these are all added up. These are all coefficients now. And then I'll deal with the A and the B. So the A is the 2x, okay? So I've got to do A to the highest exponent, which this was a degree of 8, so my highest exponent in this case is 8. All right, my A goes down to the 7th, so 2x times 7, and on its way down, so 8, 7, 6, 5, 4. Let's keep it going, and if I did it right, I'll end with none of them at the 1. 0 of them, so let's see, 3, 2, now I've got a single one of the 2x's and 0 of them here. Okay, that's a good sign. Now I'm going to take the b here. Keep in mind it includes the sign. It is a negative yz. I start out with 0 of the negative yz's. Oops, squeeze this in, then I get one of them, and then I get 2 of them like it's squared. And then it's got 3 of them cubed. So if I did this right, I should end up with a total of this degree 8. I should end up with the highest exponent of 8 of these. So let's keep it going. Negative yz in parentheses and everything. Up to the 4th, 5th, 6th, negative yz to the 7th. Ooh, and then that means negative yz to the 8th. And that's good. I was hoping I would land it at that highest exponent, the degree 8. All right, so obviously there's a bunch of simplifying to do, but yeah, this is how I would expand it. And then number 6 here, find the coefficient of x to the n in the expansion of this guy when n equals 9. Okay, so a couple things here. Let's look at their question. Find the coefficient of x to the n when n equals 9. So they kind of want me to find an x to the 9th when I do the expansion of this. So that doesn't mean I have degree 9. I still have a degree 4 here. So I'm going to use that degree 4 in Pascal's triangle. I'm going to use this guy, degree 4. Okay, so Pascal's triangle, this is a 1, 4, 6, 4, 1. All right, so let's see here. 1, 4, 6, 4, 1. So those are all my coefficients. And then I'm going to do my a, which is an x cubed. I have to do, don't forget your parentheses, I got to do the highest exponent, which is, since this is a 4 on the outside of my parentheses here, an exponent on the outside, I've got to raise this all to the 4th. And then x to the 3rd goes down to cubed. X to the 3rd is now squared, and it should go down by 1 each time. So this is the first, and then there are 0 of the x to the 3rds here. All right, my b, keep in mind, negative is included. So I have 0 of the negative ones, then I have a single negative 1, 2 of them like negative 1 squared, 3 of them like negative 1 cubed, and negative 1 to the 4th at the end there. Okay, so let's figure out where I get x to the 9th. That's kind of their overall question. An exponent raised to another exponent, that's when you multiply those exponents. So let's see, this 3 times 4 is 12. This is my x to the 12th. 3 times 3, there's 9. Oh, this is going to give me my x to the 9th. Okay, this guy's x to the 12th plus, I'm going to have an x to the 9th on this guy. Plus, honestly, I don't even care about the rest of this right now because they just wanted the coefficient of this particular term. So let's see, if I got this x to the 9th, I'm going to do a 4 times -1, so I get a -4 x to the 9th. And that's the coefficient they were going for. The coefficient, the number multiplied in front of my x to the 9th, is -4. So that's my final answer. All right, there we go, you guys.